A, B, and CD are chords of a circle where A, B, C, and D are points on its circumference. We are given two quantities. The first one, quantity A, is the sum of length of chord AB and twice the length of chord CD. And the quantity B is circumference of the circle. And we have to find the relationship between the two quantities and select the best option out of those four options that are given. So this is a quantitative comparison question that's frequently asked in standardized tests like the GRE. And the trick option often is the option D. The relationship cannot be determined from the information given, because if you look at this particular problem, not a lot of information is given about the chords A, B, and CD. So what I mean is you can draw different combinations of the chords. So let's draw a circle AB, and we could have the chords A, B, and CD looking like this, where they're intersecting at a point. And on the other hand, we could have, a different representation of the chords A, B, and CD, where, they're not intersecting at all. And of course, you could do like different lengths of A, B, and CD. So it seems like there's not a lot of information given. And simply by looking at this, one may be tempted to select option D, because the quantity A clearly looks to be variable, because it really depends on what A, B, and CD can be, and looks like there could be many different possibilities which are not specified in the problem. But then this is sort of a trick question where we just need to hold on and just think one level deeper. So it is clear that A, B, and CD can be variable. So the quantity A, which is AB plus twice CD, would be also changing depending on what combination of A, B, and CD we pick, which seems like there could be many different options there. But one of the things that we need to find out before we jump to conclusion D is, what is the limiting amount on the quantity A? By that I mean is there a maximum possible value that quantity A can take? And then if we compare that to quantity B, that might give a bit more insight into what relationship quantities A and B have. So for that, we ask the following question: what is the maximum possible length that a chord of a circle can take? So we consider the maximum possible length, and it seems like it's going to be the diameter, right? A chord of a circle, the longest chord of a circle is the diameter. So that's the largest possible length the chord of a circle can take. So if we now look at AB and CD, and if we assign the maximum possible length that they can take, then we can write this inequality. So AB plus twice CD will be always less than equal to D plus 2D, where D is the diameter of the circle. And that makes AB plus twice into CD, so that's the quantity A, less than equal to 3 times the diameter. So what about the circumference of the circle now? So the circumference is basically 2 pi r. 2r is the same as diameter, so replacing 2r by d, we have pi d. Now the value of pi is approximately 3.14. It's clearly greater than 3. So the circumference of the circle therefore should be greater than 3d. So what we find is that the maximum value that quantity A can take is actually lesser than the circumference of the circle, because the circumference of the circle is greater than 3D, and that's the maximum value that the quantity A can take. So even if we maximize quantity A, it's still going to end up being less than quantity B. So the quantity B should be the correct answer in this case, even though at the first glance the problem appeared as if there's not enough information given, but with one level deeper thinking, we are able to find out that clearly there's no scenario where quantity A could be greater. Therefore, quantity B is the greater of the two. So, going on to the next problem. ST is a diameter of a circle, and this question actually comes with that figure, so that's kind of nice. VS and UT are chords of the circle. Angle TUV is given as 45 degree, and angle UVS is given as 60 degrees. And we are asked to compare angle TMV. So M is the point of intersection as given in the figure of ST and UV. And we are asked to compare angle TMV with 100 degrees. So that's the quantity B. So in this question, we take the help of a theorem which states that angles subtended by the same arc at the circumference are equal. So in the figure, if you look at the arc TV, it subtends an angle TUV, which is 45 degree, at the circumference. And another angle that the same arc subtends at the circumference is angle TSV. So angle TSV, therefore, must be also equal to 45 degrees, because angles subtended by the same arc at the circumference should be equal. So angle TSV must be equal to angle TUV, which is given as 45 degree. So angle TSV is 45 degrees. And we have been asked to find what angle TMV is. So we know that TMV and angle VMS, they should add up together to 180 degrees. So they're supplementary angles, right? So what about the angle SMV, which is in question mark? So that's basically, together with angle MSV and angle MVS, they are angles of a triangle, the triangle MVS in this case, right? And those three angles, because they're angles of triangle, should sum up to 180 degrees. So then we can easily find what angle VMS is, because we know the other two angles of the triangle. They're 45 degree and 60 degree. So angle SMV or angle VMS, which is the same thing, will be equal to 180 minus 60 degrees minus 45 degrees. Do the math, and that comes to 75 degree. So angle TMV will be simply 180 degree minus 75 degree, and that comes to 105 degree. So the correct option in this case will be the quantity A, that's greater than the quantity B, which is given as 100 degrees.